So we left off here, we talked about, let's just back up a minute, we talked about making measurements and about reading between the lines. So we looked at this thermometer and we see that there are markings at every 1 degree. And so when we read this level here, we're going to estimate where it is between these two lines, because the lines give us very clear indication that this is between, where'd my pointer go? Good. It's between 103 and 104. And so we're going to estimate in between. So when we look at numbers that somebody else has written, we need to be able to identify what are significant figures and what are not. And so we have some rules for counting significant figures. So the first rule is that all non-zero digits are significant. So the example in this number 1.05, the non-zero digits, of course, are the 1 and the 5, right? You might say, well, duh. It's okay. In this number, we have 2 non-zero digits. Those are going to be significant. Remember, the significant digits are all of the certain digits and the first uncertain. There's always going to be one uncertain digit in a correctly written measurement. The zeros are what get a little confusing. There's 3 kinds of zeros. Did you realize that? They all look the same. They're just like zero-shaped, but there's 3 types of zeros. Interior zeros, I also call them trapped zeros. They're between 2 other numbers. So like in this number, 4.0208, there are 2 interior zeros. This one and that one. They're stuck between non-zero digits. Those are always significant. And in the number 50.01, there's a trapped or interior zero. So those are significant. Trailing zeros are significant sometimes. What's a trailing zero? A trailing zero comes at the end. So if you think of a number like a train, and we always read from left to right, we start with the 5, and then we go to the 1, and then we go to the 0. The 0 is coming at the end. It's a trailing zero. The trailing zero is a significant figure if there's a decimal point in the number. So in this example of 5.10, there is a written decimal point. And so this is a trailing zero with a decimal point. We count that as a significant figure. In this number, 500.0, these are all trailing zeros with a decimal point.
So in the example above, with 0.0110, is the last zero in that one significant?
Yes. This is another example of a trailing zero where there is a written decimal point in the number. These are the other kind of zero, which is a zero that comes at the beginning of a number. We'll talk about that one next. So, trailing zeros where there is an implied decimal point. It's not specifically written. If we look at this number, 50,000, is there a written decimal point in the number? No. Do we know where the decimal point would be? Sure we do. It's after the last zero, but they didn't write the decimal point. When we see a number like 50,000, that's probably kind of an estimate, isn't it? Say, oh, well, the population of this town is 50,000. Does that imply that they actually counted everybody and there was exactly 50,000 people? No, it's just kind of a round ballpark figure. So these are trailing zeros without an implied, without an expressly written decimal point. So 50,000, 50,000, those 4 zeros are trailing zeros with no written decimal point, and the number 10. Now, if you say something is 10 feet long, does that mean it's exactly 10 feet? Probably not. So 2 kinds of trailing zeros, and then we have these leading zeros. Leading zeros come at the beginning of a number, 0.0005. All of those zeros are at the beginning. They're before the first non-zero digit. Those are never significant. Why do we write those zeros? Why don't we just write 5? They're placeholders. If we left them out, the magnitude of the number would be very different, right? We need them to show that this is a small number. And here this number, 0.0153, those leading zeros. Do those numbers tell us that something was measured there? Not really, no. If we take an example of, maybe we measured something and it was 5.5 centimeters. If I put a 0 in front of that, now that looks funny, would that change the size of the number? No. What if I put 3 zeros? Looks funnier, but it's still the same number. Those are not implying a measurement. They're not considered significant figures. Because if we wrote 1, why not write 1,000? So the zeros that come at the beginning are not significant figures. They only serve as a placeholder. We learned about scientific notation on Tuesday. What would this number, 0.0153, be if we wrote it in scientific notation? 1.53 times 10 to the negative 2. We need to move that decimal place 2 places, and that's a small number, small paycheck Mrs. K feels negative about, so it's a negative exponent. What happened to those leading zeros? They went away, didn't they? Now this times 10 to the minus 2 is taking their place of holding where the decimal point is supposed to be. Then there's also some numbers we call exact numbers. When we think of an exact number, we don't really give it a specific number of significant figures. It basically has an infinite number of significant figures. And examples are exact counting of discrete objects. How many fingers am I holding up? 4. Is there any uncertainty in that? 1, 2, 3, 4. There's exactly 4. It's not a measurement made with a ruler or a balance. We counted them. And so if we say 4 fingers or 12 pencils or 9 pennies, then that's an exact number. Other examples are integral numbers that are part of an equation. Something like the diameter of a circle is 2 times the radius. This number is an integer. An integral number, it's part of the equation. That is an exact number. And so that has an infinite number of significant figures. Defined quantities. Some conversion factors are defined quantities. One example is that 1 inch is exactly equal to 2.54 centimeters. That's defined. 1 foot is equal to 12 inches. That's defined. So those numbers have an infinite number of significant figures. So let's do some examples here. So how many sig figs in each of these numbers? A, 0.0035. 2. These zeros come at the beginning. They're just holding place for the decimal point. So the 3 is significant and the 5. The 5 is uncertain. There was an estimate there, but we always include one uncertain digit. How about 1.080? That has 4 significant figures. Obviously, the 1 and the 8 are significant. This is an interior 0, and this is a trailing 0 with a written decimal point. So in this measurement, this thousandths place was estimated, and we estimated that it was 0. So we don't want to just leave that off because then we're throwing information away. How about 2371? 4. That one's easier because there's no zeros. How about 2.97 times 10 to the 5th power? 3. This part of scientific notation, the times 10 to the something, that's the decimal place holder. So in any number written in scientific notation, all of the digits in the coefficient, the first part, are going to be significant. We'll never have any leading zeros there, will we? Because proper form for scientific notation is a non-zero digit first, so there's no leading zeros. 1 dozen equals 12. That's an exact number. So if we were pressed to give a number of significant figures, how many sig figs does that have? Infinite. Infinite. So that's a symbol for infinity. How about 100.00? 5. These are trailing zeros. There's a bunch of them, but there's a decimal point. So 5 sig figs in that one. How about 100,000? 1. There's trailing zeros. There's no written decimal point. So that has 1 sig fig. Now, if I wrote this 100,000 and put a decimal point there, then how many does it have? 6. This is a notation that scientists sometimes use. It's not something that is the best form because it can be a little confusing, especially if you're writing numbers in a sentence and you've got a decimal point at the end of the sentence. You're like, well, is that a period or a decimal point? Hard to tell. If we want this number to have 6 significant figures, the best thing to do would be to write it in scientific notation. So this would be 1.00000 times 10 to the what? Times 10 to the 5. So we need to take this decimal point and move it over 3, 4, 5 places. Writing it this way, we are very clear to the reader that those zeros are significant. If we take this number and put it in scientific notation, it's going to be 1 times 10 to the 5th with 1 significant figure. Any questions? Learning significant figures is a little bit like learning how to play poker or bridge or Monopoly. You read through the rules or someone tells you the rules and at first you're like, okay, whatever, didn't make a lot of sense. And then as you play the game and people correct you, oh no, you can't do that, you can't play that card now, you have to wait for this. No, you roll doubles, you have to roll again. As they correct you, then it begins to make a little more sense. And after you've played it for a while, you just remember the rules and you don't have to think about it. So that's how I see significant figures, is there's some rules we need to learn and then we need to practice a little bit. And if you keep practicing, it'll make sense.